Hey y'all, it's me, Miss B, and today we are talking about factoring. We're factoring trinomials and binomials of quadratic expressions. First, let's do some vocab. First, factoring is rewriting an expression as a product of its factors. Okay, some examples of that would be 10 equals 2 times 5. You've got 6x to the third, that's 2 times 3 times x times x times x. And then we'll get to doing this, but x squared plus 2x plus 1 is factored as x plus 1 times x plus 1. All right, the greatest common factor of an expression. This is going to be something that's really important, but a lot of people forget about. So, greatest common factor is the largest number that divides every term in the expression. Okay, we talked about quadratic functions before. It's f of x equals x squared. Those were previous notes. A binomial is an expression with two terms, hence the bi. So an example of that would be x squared plus 2x. And then a trinomial is three terms. For example, x squared plus 3x plus 6. Okay, so factoring binomials, again, binomials are expressions with two terms. So what we're going to do is we are going to pull out the GCF. Okay, so I'm always going to ask myself, what is the greatest number that divides both terms? So when we have a two-term expression, we're always going to use the GCF. So for this one here, I have a 2 and I have a 98. So what's in common is the 2. So I'm going to pull out the 2. Then I say, okay, what's 2x squared divided by 2? And then what's 98 divided by 2? So then I get 2 times x squared minus 49 is how that simplifies. Okay, so it's like undistributing. Because if we were to redistribute this through, we would get this answer right here. All right, let's try another one. Let's try this one here, 4. So I have 9x squared plus 27x. So I'm going to focus just on the coefficients first. So between 9 and 27, 9 divides both 9 and 27. Then I'm going to focus on the variables. So for x, the smallest degree that I have is a 1. So because that is the smallest degree that I have, I can only pull one of those x's out. So the biggest thing that divides both of these is 9x. So I'm going to take 9, let me make my pen smaller. I'm going to take 9x squared divided by 9x and 27x divided by 9x. And so then 9x is equal to 1x plus 3. You don't have to write this out every time. but I am because of the fact that these notes are online. Okay, let's do another one of those together. So I've got 12x squared and 100x. So between 12 and 100, the greatest number that can divide both of those is 4. Between x squared and x, I've got x to the first. Because I have an x squared, because I only have an x, this greatest thing I can pull out is 1x. So then I'm going to divide 12x squared by 4x. 12 divided by 4 is 3, and x squared divided by x is 1x. And then I'm going to do 100x divided by 4x. So 100 divided by 4 is 20, and x divided by x is 1, so that's just left as 20. Oh wait, 25. Ha! Duh. All right, and that right there is our final answer. I want you to go ahead and do the last 3 on your own. So this one here, I'm going to factor out a 3, and so then I'm left with x squared minus 8. On this one here, 5 is the biggest thing that divides, and so I'm left with 2x squared minus 5. Then for this one, I can pull out a 7x, and so I'm left with x plus 2. The way we would read that is 7x times the quantity x plus 2. All right, now let's move on to factoring quadratic equations. I always set this up the same exact way every time. That way I can't make any mistakes. So I'm trying to find two numbers, x and y. These two are going to match up, and these two are going to match up every time. But they need to add to be b, that middle value, and they need to multiply, that should be a multiplication symbol, to be a times c. So we're multiplying these two terms together. Let's jump into a few examples. So here, I need to add to be b, and I need to multiply to be 1 times 20. So then I need to think of two numbers that add to be 9, but multiply to be 20. So I start thinking of numbers that multiply to be 20. I've got 1 and 20. I've got 2 and 10. I've got 4 and 5, and that's it. You'll notice that 4 and 5 are two numbers that also add to be 9. So 4 and 5 are those numbers. Because I have a coefficient of 1, and I would write this down, I don't need to split the middle. We'll get to split the middle in a couple of lessons. So I can just write my answer as x plus times x plus, and then I'm going to put my 4 and my 5 in there. All right, let's do another one. I've got a coefficient of 1, so I need two numbers that multiply to be negative 72, but add to be 14. So let's think of some numbers that multiply to be negative 72. So I have, let's start from the middle. I've got 8 and 9. No combination of those are going to be 14. I have 3 and 12. What's 72 divided by 4? 4 and 18. Now 4 and 18, if we think about that for a second, negative 4 plus positive 18 gives me a positive 14. So that's the correct combination. So the negative 4 times 18 is in fact negative 72. Because we have a coefficient of 1, we can write our answer as x minus 4 times x plus 18. Okay. Let's do one with the negative out front. So when I have a negative out front, I'm always factoring out that negative sign. So I have negative x squared minus 3x plus 12. But when I write my final answer, I need to remember to put that negative out front again. So I need two numbers that multiply to be 12, but add to be negative 3, because I'm using these numbers here. So let's think of some numbers and multiply to 12. I've got 1 and 12, 2 and 6, 3 and 4. You know what? This one doesn't even factor. So this one does not factor evenly. It's prime. And that's because we couldn't come up with numbers, two numbers that multiply to be 12 and add to be negative 3. All right, let's do number 5 then. Let's factor out that negative. So I have negative x squared minus 14x minus 32. I need two numbers that multiply to be negative 32 and two numbers that add to be negative 14. Let's go through. So 32, I've got 8 and 4. That's not going to work for 14. I've got 2 and 16, and you know what? I can make a combination that is 14. If I have a negative 16 and a positive 2, that gives me negative 14, and that does multiply to be negative 32. So I'm going to write my final answer as, remember that negative out front, because we factored out that negative right there, and then I have x minus 16, x plus 2. All right, I'm leaving the other ones for you to do on your own. For this one, you should have had x plus 10, x plus 4. And then for this one, you should have had x minus 5, x minus 6.